Some fuel systems use primary and secondary fuel filters, while other systems operate with only a single filter. Certain other systems depend on a fuel filter as well as an optional fuel-water separator filter. Primary filters typically have more open and less restrictive media. They are built to capture large particles and to permit greater flow of fuel. The main responsibility of the primary filter is to protect the fuel pump from contaminants. For this reason, the filter is usually mounted before or on the vacuum side of the fuel pump. Secondary filters have tighter media than primary filters and are designed to capture finer contaminants that often damage the injector tips and the injection pump. When a secondary filter is being used, it is located after or on the pressure side of the fuel pump. If only one filter is used, it is normally found on the vacuum side of the injection pump. While optional on many systems, some engine manufacturers require the use of fuel-water separators, which serve the same purpose as primary and secondary fuel filters. In addition to removing contaminants, fuel-water separators are used to strip water from the fuel. Fuel-water separators can be used either as a standalone filter or as a primary fuel filter along with a secondary fuel filter. The Baldwin-Dahl fuel-water separators offer an additional line of defense for applications where significant amounts of water need to be removed. These units use a three-step process to remove water and contaminants. When the fuel flows into the Dahl unit, it is spread out by a depressurizer cone. As the fuel leaves the cone, approximately 80% of the water and large contaminants are removed. The fuel then rises, coalescing water droplets on the cone and baffles. These droplets are heavier than the fuel itself and fall to the bottom of the bowl. The water and contaminants can then be removed through the drain valve. The fuel then flows through a filter, where additional smaller contaminants are removed. To better understand how a fuel filter, as well as a fuel-water separator works, let's take a look at the components of a typical heavy-duty fuel-water separator. The primary components are a base plate assembly, a bottom end cap, a center tube, the filter media, a top end cap, a compression spring, a self-venting drain valve, and the canister. Some fuel-water separators contain a water sensor port for the use of an electronic water-in-fuel sensor. Fuel enters here, is filtered through the media, passes through the center tube, and into the engine. On fuel-water separators, water that is collected during this process is released by turning the drain valve. To ensure quality fuel filtration, Baldwin utilizes industry-standard test procedures to determine efficiency, the removal of contaminants, capacity, the storing of removed contaminants, and flow rate, the ability to move fluid through the filter. Using these industry standards helps ensure quality fuel filtration. The various test procedures used include the SAE J905 for life and efficiency, the SAE J1985 for single-pass efficiency, the SAE J1488 for water removal, and the ISO 19438 for particle removing efficiency by size. Be sure to request comparative test data when comparing similar products from different filter manufacturers. When choosing a fuel filter, consideration must be given to the filter's efficiency as it relates to its capacity. A filter with high efficiency often means reduced capacity because the media is more restrictive to flow. The life of the fuel filter will be shorter because it captures smaller contaminants. A filter with high capacity often means reduced efficiency because the media is less restrictive to flow. The life of the fuel filter will be longer because it allows smaller contaminants to pass through the filter media. In both situations, you'll find a middle ground between efficiency and capacity is desired.